So now that we've actually practiced recognizing some of this stuff, we will try graphing our own. Degree 1, that is just x. So x or x minus 2, or, oh, it's a line. With a negative leading coefficient means it's going to go down. Again, so if I come from the right and back it up, it's a nice little line going down. Degree 3, positive leading coefficient, 2 real zeros. Okay, so if it's 2 real zeros, I'm going to have to make one bounce. Okay, so positive leading coefficient made it start from the right. Notice with odd degree, it ends up going in 2 different directions. Degree 4, 3 turnaround points, positive leading coefficient. Okay, positive starting up from up and heading down. Let's see, 1, 2, 3 turnaround points. Notice it never actually has to hit the x-axis at all, although I could have drawn it down further and it would have. Okay, so where are my turnaround points? They are blink, blink, blink. Maybe I'll put my 2 turnaround point, 2 zeros here. Okay, so degree 5, 3 turnaround points. There would normally be 4. So I must have had 1 cubic turn. And it turns out, well, you can put it anywhere. Starting from positive leading coefficient, I could keep straightening out my curves. I could put it right here to turn around and not actually go up. Okay, and then 2 third turnaround point. I could have done, the first time I drew it with the turnaround point on the left and the regular min on the right. Okay, so this next one, degree 4, negative leading coefficient, it's upside down, 3 turnaround points. So one thing about degree 4, we call them quartics, degree 3 is cubics. They tend to look like W's or upside down W's. And this one's upside down, let's see. Negative leading coefficient, we're coming from the bottom, and we turn around once, twice, 3 times. Doesn't have to be at the same height. Okay. So turnaround points, 1, 2, 3. Degree 3, positive 2 turnaround points, that's the normal thing. So I start from the top. If I only want it to cross and have 1 real zero, then I need to make sure I don't bounce down below. So 2 turnaround points, only 1 zero. Okay, so Haven't done too much with the zeros in actually creating the graphs if you don't have the polynomial itself, because the number of zeros, it turns out, it's hard to do. Even with parabolas, we know that they don't have to bounce down to the x-axis or below the x-axis. They can stay above. They don't have to have any zeros at all.